Welcome, everybody. We're going to be working on the second set of Chapter 2 exercises this week. Before I dig into the 4 exercises I have there, I do want to get into a little bit of what I call a string demo. And yeah, this is not Spider, and I get that, and I should probably get Spider launched in the background here. So I'm going to let that launch as I'm kind of showing you what I have here. Right now, the program that I have up on my screen, if you guys are curious, this is called Notepad++. Before Visual Studio Code was a thing, this was kind of the program that was like it. And like Visual Studio Code was very capable of being having a lot of extensions written for it, although people have kind of dropped off. I really like it as a text editor, which is why I use it. And normally when I do like cheat sheets for coding classes like this is what's up on my other screen with all the answers. And actually I have the exercises are up here in tabs ready to roll. But what I wanted to do here is talk about how we use strings and the different approaches, just so that we're really clear about how this stuff works. And okay, so some of this is a little bit superfluous, right? Like the print statements that we have here. I think we're pretty comfortable with those now. Here's a prompt for a user to capture some text from the screen. And then what do you do with it when you capture it, right? I just want to remind you that we have basically a few different approaches that we use for doing output inside Python programs. And we have I'm going to call it the old school basic approach, which still works just fine, right? Where you take a string of text and you just take the variable and add it to the end of the print statement, separated by a comma. And this is kind of like the parameterized approach of doing this. So like you have text, that's one parameter. You have a variable, that's another parameter, and it just puts it together. You can also, if the variable has text within it, you can use the concatenation symbol. And I would say that this is not really a very Python-esque approach. This is more like a Java approach or a C# approach, but it does work. My strong recommendation is to use the F string approach, right? This is where we put an F at the beginning of the statement and then embed the variable inside of curly brackets inside the code. Right? So this is just to kind of reinforce all the concepts that we've looked at. Now, if your user is inputting a number, you have to remember that whatever we capture at the keyboard comes in as text. So if I want it converted to a number, it's very common to take an input statement and put it inside a numeric conversion function. In this case, converting it into an integer, but we can also convert it into a floating point number if that's what we need to do our calculations. But remember, anything that comes in from the keyboard comes in as text. If you need it to be a number, you have to convert it to a number, right? And then, of course, you can output it, you can do math with it, or whatever you wish. All right. So I think that covers most of what I really want to focus on here, but there's also a couple of functions that we can look at that do come in very handy. I'll reiterate these again next week, because we use these a lot when we code. One of them is the length function, and that is where we take a string, for example, and we go, okay, how many letters are in that string? And it's very simple. You can brute force add a string to the length function, like inside the parentheses, or in this case, we have a variable that holds a string and put it in there. And then this would respond if the word inside the variable is whatever. What would be the length response for this? Well, you can count. There's 1, 2, 3, 4, 5, 6, 7, 8 characters inside there. So the response would be 8, right? Next week, we will learn about the fact that strings are complex objects, and each one of those letters has an index value that kind of puts it into an array structure, but that's kind of next week. But that's really handy to know how long a string is sometimes, especially if we're doing processing on it, right? So a very useful function. There's these other, what we call methods, right? And you notice how methods they look like functions. They have parentheses after them. But these are using what we call dot syntax. So I can take, for example, this username variable that I captured up here, and then when I add a string method, upper converts it all to uppercase, or it converts it all to lowercase, or we can capitalize it, meaning making the first letter capital if it isn't already. And this is kind of like weird little string methods. These are just a few of the string methods that are out there. There's many more, but these are ones that we use quite a bit, upper, lower in particular. And when we learn if statements, what you guys will figure out is that these are handy when you're trying to, let's say, not have to check too many conditions, right? Or if you want to, convert something to a different format for a particular purpose. All right, that's my little string demo. And so let's just move on from there. So there's my solution for the next exercise, by the way. And if you're really fast, you could have screen captured that, but too late now, right? It's in the recording. I have all my old exercises open here inside of Spider, so I'm closing those. I'm going to go ahead and create a new file, which happens automatically when you close them all. And then I am going to do a save as right out of the gate. And my challenge for you guys is to catch me once that I don't do it. See if I fail once this semester. I'm going to store this in my Python folder. So we do start with a little bit of file management here. And you can see I have a folder for Unit 2, Part 1. Now we need a folder for Unit 2, Part 2. And all the exercises will go here. The first exercise that we're working on, I forget its number. It's exercise 2.7. So I'm going to call it EX2_7. There's the save. Zooming in on both panels. Do Control plus or hold down the Control key and scroll on your mouse wheel, by the way, if you're wondering how that's done. All right, let's read the first exercise description. Exercise descriptions are, of course, attached here. So I'm just going to pull up that document. I probably have it somewhere on my hard drive already, but whatever. I hate hunting for it. So I just do this because it's a little bit faster. So we're going to go to exercise 2.7. And here's our programming prompt. Write a program that prompts a user for the radius and then prints the area and circumference of a circle with that radius and the volume and surface area of a sphere with that radius. And if you're already going into panic mode because there's math and formulas involved, please take a deep breath and hang tight because the formulas are out there. We don't have to write them on our own, is what I always tell people. So I'm going to take that description and drop it in here in the form of a comment. And of course, I grabbed that superfluous 7 there. And then I'm going to transport us to the magic of Google. Right? And so the first formula that we need to figure out is the area and circumference of a circle. All right, let's do them one at a time. That's really 2 separate formulas. So I'm going to go and just search for that. So I'm going to say area of a circle. And if you want, you can say formula, right? But here it is. Here's the formula. The formula is basically the area of a circle. So A equals pi times the radius squared, right? And if you want, I don't know if I can copy and paste this over. That's entirely possible. Let's see if it works. Let's see if it pastes in. Yeah, I guess it did, right? Not pretty, but we have to remember that this is an exponent, by the way, and we could put it into Python speak right away and just do that. Right, so there's the one formula. The second formula is, and I'm going to do this in a separate tab, and you'll see why later. We're looking for the circumference of a circle. And in fact, I'm a lazy typer. So let's just copy that and then paste it into the search engine, right? There we go. And here's the formula for the circumference of a circle. So once again, I'm copying it and bringing it back over to Spider and putting it up here for handy reference. And then we need 2 more formulas, the volume and the surface area of a sphere. And we'll just take them one at a time. Volume of a sphere. Like it's listening to me or something, right? And I'm not sure which one of these is gonna, I think this one will paste better. So I'll just copy that. Hey, the exponent copy, that's pretty slick. All right, and then it was the surface area. Once again, it seems like it's listening. and that's okay when it makes my work flow faster, right? But here's all my formulas, and that one didn't come in as an exponent, but I can mark it like that. So there's all our formulas for reference. Now here's a problem. What is, and I'll just do this with Google, right? What is the value of pi, right? Okay, so some of you might have this memorized, but I'm going to venture that most of you don't. I used to, when I was, studying way back when, I kind of had it memorized. I don't know how many decimal places, and it's kind of like when I get past that point that I kind of forget, right? Now, the truth is, pi is one of those constant numbers that after the decimal point never repeats and goes on to infinity. It's really a bizarre number, right? Um, and so there's an infinite level of precision that's involved with it. But usually for most calculations, you can kind of round it to 3.14 or 3.1415 or something to that level. And it usually is pretty accurate in the calculations, depending on the precision that you need. If I was trying to land a man on the moon, I'd want as many digits as possible. If I'm trying to like figure out the volume of this can of sparkling water, that's a little bit different, right? But basically, pi is derived from the mechanics of working with a circle, right? And this is stuff you learn in math class, and I'm not here to teach you math, but it is a value that you should know. They use the Greek letter pi, or in Greek we actually say p, right, to represent it mathematically. Now, here's the problem. I can't write code. Apparently I can drop it into the editor, but it doesn't know how to respond to the letter pi in the code. So like we did last week, we are going to do an import of pi from the math library. So here is the import statement. So I want you guys to all type this in. So from the math library, we will import pi as a value. So wherever we want to use pi in a formula, we just use the pi and it will work, right? So that's a pretty standard thing. Now, this little warning, if you're wondering, is just saying, hey, you imported it, but you're not using them. Of course, I just typed it. Correct. You are absolutely correct. Now, one of the things that's, I think, pretty important here is the fact that we're prompting the user for a radius. So we're going to allow the user to type in the amount of a radius. Well, let's just have this discussion right off the bat. Should this be an integer or a floating point number? Right. Now, if you're thinking floating point number, your brain is on target because we're already dealing with decimals, right? And we're doing division and exponents and all that stuff. And frankly, we don't know like what units of measure we're using, if it's like meters or millimeters or yards or whatever. So we can't really kind of truncate anything. I think we need to use floating point numbers. So we are going to store basically the radius. So we're going to just make a variable called radius. I'll write the prompt first. So open and close parens, some double quotes here, and then I'm just going to ask the user to enter a radius or enter the radius. And I'll leave a space at the end there. And then, of course, we want to convert that into a floating point number. We can do this two ways, right? And I think I showed you both of these already, but I'll do this approach and then switch to the approach, which I think is better. So I can use the float function and then take the variable I already captured, run it in the float function, and store it back in the same variable. That works. Or I can be more clever, and I can take this float function and just wrap it around the input statement, which I think is a better approach generally. And experienced programmers go to that approach every time. I know I've mentioned this before. Repetition doesn't hurt a thing. So this is the approach I would recommend, right? So that part is basically reading the radius from the user. Next, we're going to do some computations. So the first computation we're going to do is we're going to compute the area and the circumference. The first bullet, basically, we have the formulas. So all we have to do is convert those formulas into Python speak. Now, isn't it really kind of cool? Because like I researched it first, right? I copied the formulas over and they're right there on the screen. So I don't have to go hunting and then switching screens and all that kind of goofy stuff. So let's just go ahead and use this. So let's do the area first. We'll store the result in a variable called area. And the formula is pi times the radius, right? And I guess I could have used the letter R, right? I could have, in fact, we could just do it that way. Let's just do the letter R, because then it looks more like the formula. And then that is also squared, right? So I could do R squared. That would be one approach. And I know this looks kind of weird because they're kind of separated. Now, given the order of operations, and I want you to remember this, do exponents calculate before multiplication? You should be nodding right now. Yes, they do, right? Remember this PEMDAS thing? Please excuse my dear Aunt Sally, right? Parentheses, exponents, multiply, divide, add, subtract, right? You learn this in math and you hear it in every programming class, by the way. But if it helps you, you could put parentheses around stuff if that's what's necessary. The other approach to this, and you can do it either way, right? R squared is the same as R times R. That would work too. So either approach would be fine. I am putting the exponent kind of like right next to that. Either approach is okay. So that's the first calculation. Then we have the circumference. Well, okay. And hey, if we're like abbreviating anything, let's make area A, right? And then we can do circumference is C. Oh, now I see a problem already though, because we have one area for the surface area and one for area. So I guess when we do surface area, we'll go SA. Sounds reasonable, right? Right. So circumference is 2 times pi times r. Piece of cake. 2 times pi. And I like to put spaces in between stuff usually, but you don't have to, by the way, times r. Next, we're going to compute the volume in the surface area, right? And we have formulas up there once again. And let's do V for volume. And I'm going to argue, like from a variable naming perspective, it's kind of attractive to do these like just single letters. However, right, and really the convention in modern programming is be super verbose. Like it might be better to call a variable surface area of a sphere, like be that verbose, where it might be better practice. I'll let you be the judge of what you want to do. So this one is 4 divided by 3, 4/3. It's really a fraction, but that's really what it means, right? And then we're going to multiply it times pi. And then we're going to multiply it times the radius raised to the 3rd power. Correct? Does my formula look okay? It does. So that's the volume computation. And then we already decided surface area will be an SA. And that formula is 4 times pi times r squared. Once again, I'll reinforce this. I know I said it last week too. When it comes to knowing these formulas, a lot of them you can just look up online. If you're working inside of an organization where they have a mathematical calculation based on some scientific research or a calculation that an actuary gives you to do financial calculations, they're just going to give you the formulas. There's going to be an engineer or somebody that's going to have the formula. So here's the formulas you need for your program. And then your job is to do what we just did, convert it to Python syntax. Right? Usually you will never be formulating the formulas. I say usually. Right? It depends on how deep you go, folks. Next, we display the results. So there's a number of different ways to do this, right? And my approach would be that when you do this, your output should be verbose and descriptive. So a couple things that I would do here. First, let's start with a print statement. Inside that first print statement, I'm going to put some double quotes. I've already decided I'm going to use the F string approach, and then I'm going to do a separate output for the results of each formula. So here's what I'm going to do right off the bat is I'm going to take that basic print statement and just paste it 4 times and then add my content, right? Seems pretty logical. With the first one, I'm going to start with an escape sequence. So I'm going to put a blank line at the beginning of it. And that, in fact, I like that approach at the beginning of a program. So I'm going to put it in my prompt also. Right. So that way, when the output comes out, it's not like touching, it's down a line. It's just easier to read, right? Create a little space. And then we're going to say something silly. Okay, so the first formulas are related to circles, right? So we can say area of the circle is, and if you want, you could get it even more verbose. You could say area of the circle with a radius of blank is, you could do that. I'm just going to just output the area. And I want to format it, right? So I'm going to pull in my variable here, and the variable is A, but I want to format it to how many decimal places do you think is reasonable? Okay, so this is very subjective because we really don't know the units of measure, is what I'm going to say, right? Like it could be like millimeters, or it could be, kilometers. We just don't know. So we're just going to pick an arbitrary level, and we'll go. Notice the colon here after the variable name. We're just going to go dot to F. That's kind of what we've been doing all along. But you could make it 3 decimal places or 4 decimal places. In fact, why don't we just do that? Let's go 4 decimal places just for the heck of it, just to try it. All right, so there's the first one. And then here we'll say, what's the next one? Circumference. And I noticed that I didn't put a space here, and I wanted to, so I'm going to add it now. Then our curlies, and the circumference is a C colon, and we'll use the same level of precision for all of these. And we might find that that's not necessary, but hey, let's see what it looks like first and then change our minds later. Right? Instead of saying a circle, we should say the circle. And here we'll say, let's see, what are we doing? Volume of a sphere, right? And that's just going to be the letter V. And then we should still be in my buffer there. Paste it in. And then we can also say surface area of the sphere. Curlies. And we're using SA this time in a colon, and then the same formatting command. Now, I might argue that I might want an additional print statement here. So I'm just going to type one in, and you can see what my thinking is here. And I'm going to say inside here, so I'm going to take this escape sequence and put it up here. And I'm going to say, given a radius of, and I'm going to repeat the input information back to the user, right? And I'm going to also use the same formatting command. I'm going to round it, or, I don't anticipate they'll type 4 decimal places, but they might. And so, my thinking is, all right, you type something in, I'm acknowledging that you typed it in, and then I'm giving you the calculations that go with it. Right. And folks, this is the completed program. That's all there is to it. So let's go ahead and save this and run it. And of course, we're being prompted. Now, here's what's really helpful, by the way, and I'm not going to do this to, go back and forth between screens, but I'm going to just type in a number, 2.135. It's coming up with one off the top of my head. Now, I'm also going to copy this, by the way, and I could go out to these formulas that I've pulled up, so for example, like the area of a circle, And the way that Google does it on screen, I can just put that value in here and it'll tell me what the answer is. And notice it's approximately 14.32. So Google thinks 2 decimal places is enough. But this is a way you can check to see if your code's working. So if it's really close to that, you know it's working. And I think I've mentioned this too, right? It really is a good practice the first time you run calculations in the program, or several times, that you test the calculations in something external to the product. So, okay, so there's the radius. So now I'm repeating it back. And then notice the area of a circle, circumference, volume of a sphere, and surface area of the sphere. We don't know what the units are, by the way, whether it's millimeters, yards, whatever, inches, it doesn't really matter. It would work for any of those. Right, so this is the running program. This is program 2.7. All right, we are at break time, folks. So I'm going to take a 5-minute break and pause the video. All right, as I ran this, I also wanted to remind myself and you guys that the variable explorer up in the upper panel here, where you can look at the stuff that actually gets stored in the variables, and that you can see that like the formatting commands are really what they're doing and how they're rounding, right? There is rounding that happens when we truncate something. But I think that's always kind of interesting to look at. I don't normally look at that too much, but it's up there. And if you're wondering what goes in, there you go. All right, our next exercise, very similar to what we just did. This is exercise 2.8, if I remember correctly. And I am bouncing screens to try to find it here. All right, so we're doing this. Write a program that asks the user for the lengths of the sides of a rectangle, then print the area and perimeter and the length of the diagonal. This sounds a lot like what we've already done, right? So that we are going to actually work on this one. Did we do this last week? Now I'm having this like brain moment here. I almost kind of feel like we did this last week, so I'm going to like look here in the course shell. So I apologize for fumbling on screen with this. But hey, this is a live class session. No, we did not. We did one that was really similar. I think 2.6 was really similar to that, is what it was. All right, so we're just going to proceed with this. So I'm going to get into Spider here. I'm going to make a new program. Save as. This is exercise 2_8. And then what I'm going to do here is, aside from just zoom in, I don't have the programming prompt, but I have this little thing that I put in here at the top last time, which was this: compute the area, perimeter, and diagonal length for a rectangle. And we allow the user to enter the length and width of the rectangle. All right, we know from our experience already that once again, we're going to pull from the math libraries and we're going to import the square root function, right? I think Aaron, I think you pointed out last week, we could also raise it to an exponent of 0.5, is basically the same thing as doing a square root.
I got a question for you real quick.
Yes, absolutely.
The thing is with this program, 2.2 is the one that's similar to that. You're looking for a 8.5 by 11.
Right, we did that with a sheet of paper, correct. Yeah. So this is really, really similar to that. One of the differences to this exercise, though, is that we're allowing the user to input the length and the width and then converting it to a floating point number. So that's what's going to come next. And I am going to do this kind of in hurry up fashion here, you guys, because I want to kind of focus on the other exercises a little bit more. So I'm going to create a length variable. I'm going to create a width variable, and yeah, I'm creating them first, and then I'm going to do my inputs, which are going to be pretty similar to each other. So the one is going to say input the length, and we'll convert it to a float. I'll let you just ponder that for a second. And then we're going to have them input the width. It doesn't matter which order you do them in, obviously, because the math will work either way. Now, these formulas I don't need to look up, right? And some of you may not know the whole quadratic formula, Pythagorean theorem thing by heart, but you can look back at what we did last week. It's basically a squared plus b squared equals c squared, right? And then we take the square root to get the length of the diagonal. So we'll do the computations next. And I do like to label things, especially when you get started out. I think it's really, really handy for remembering. Area is very simple. Area is what? Length times width. And I like to put spaces in there, so I'm going to do that. That's a really simple one. Now, the perimeter is basically taking the two long sides, right? Or taking the one long side, multiplying it by 2, and then the two short sides of the rectangle are basically the width and measuring it or multiplying it by 2 once again. So the perimeter equals 2 times let's do length first, right? Because we usually say length and width, right? Let's spell it right. And then that will be added to 2 times the width. And if it helps you, you could put parentheses around these expressions, but order of operations would do the multiplication first anyhow. So this will work just fine without parentheses. If in doubt, though, right, if you're not sure what it's going to do, put parentheses around things. It's okay. So that's a very simple calculation. Now the diagonal, we can borrow from the code we've done before, and I'm not going to go hunting for that file right now. But basically, we're going to take the square root, and that's a function, by the way, of the length, a squared, basically, and we go star, star 2, plus the width squared. You could also say length times length, that would work, or width times width, that would work as well. Then all that's left to do is to put the results on the screen. And, I forgot, like from the last exercise, I put in an escape sequence here because I like that blank line at the beginning. So I'm going to do that here as well. And then I'm going to do that also in my output. Once again, because I know I'm going to have a couple lines of output, I'm going to pre-configure the statement here and copy it. It looks like I did it 3 times. So there's 3 things. And I could argue you could say, given a length of X and given a width of X, and then do the output. Sometimes users appreciate that, but I'm going to do a blank line here. I don't think it's really necessary for what we're doing here. So we can just say the area is, and what are we displaying? The area. And then once again, we have formatting commands to worry about because we are dealing with floating point numbers. This time, let's just do 2 decimal places. Let's just do .2f. And maybe you want to put a period at the end. I don't know. I'll leave that up to you. The perimeter is .2f. Close that curly bracket. And then finally, the diagonal is, spell it right, .2f on that one too. Close that curly bracket. Now let's see if it runs. So hit the run button here. And this is one of those things that I suggest you use really easy numbers to start with. So I'm going to use like a 10 and a 20. Okay, so what would the area be? Normally I'd say get a calculator out and figure out that would be 200. The perimeter should be 20 plus 40 would be 60. You guys see where I'm going with that? Like I want to know that I'm getting the right answers. So I know these 2 are right for sure. This one is a little harder to calculate in your head, but 22.36 I believe is correct. Okay. Then if you want, you can put in much more complicated numbers and see what happens. I put in whole numbers, but we do need the precision, especially when we do the diagonal, because there are decimal places at play. All right, that's exercise 2.8. Let's move on now to exercise 2.11. So 2.11. All right, it says write a program that asks the user to input the number of gallons of gas in the tank, the fuel efficiency of the vehicle in miles per gallon, the price of gas per gallon, then print the cost per 100 miles. So, how much does the drive to cost 100 miles, and how far the car can go with the gas in the tank? These are kind of interesting calculations. I like this exercise a lot because I think a lot of people don't think about this stuff when they drive a car. They just, put the gas in and go and then wonder why they're out of money at some point. And I learned really quick from having to drive to campus often. And for me, it's an hour drive, right? And that's a lot of miles. And if you do it a lot in the week, it adds up. And if you have like a car that gets like 15 miles to the gallon, costs a lot of money compared to a car that gets like 30 or 40 miles to the gallon. Or I got smart and bought a little manual diesel Volkswagen that was getting almost 50 miles to the gallon. And man, the cost savings is huge, right? Here's the programming prompt here, right? Just to remember this. And where we're going to start is by getting the information from the user. So we're going to ask them those questions. So if you want to label things, so we're going to get inputs from the user, and we're given a list. It says write a program that asks the user to input basically these 3 bullet points, right? And so if you want, you could copy that verbiage or you can reword it. So this is how I did mine. And I am copy pasting this stuff in for the sake of speed here. So the first one, I created a variable called tank amount, right? So how much fuel capacity the vehicle has. And this is a weird ask, but I would bet a lot of you don't know how many gallons of gas your car holds. I know how many my vehicles hold. I have like a big Toyota that holds 18 gallons. I have a smaller Volkswagen that holds 13 gallons, etc. And those are really good things to know, by the way. We're going to convert it to a floating point number just so we can have mathematical precision here. The next one is to enter the miles per gallon for the vehicle. So I created a variable called MPG. And notice, and this is kind of one of these little leaps I make here. Enter the MPG of the vehicle. Like a lot of people don't know what that means. Yeah, you would think they would, but you'd be surprised. So whenever you write a computer program, I always say, hey, give them more information than not. You want to abbreviate, that's fine, but at least explain to them that it's how many miles per gallon. If you're not sure, go out to Google the year and model of your car, and it will tell you what your MPG is. And I think that's pretty interesting. So like, for example, I'm trying to remember what model year that car was. It was a 2003 Volkswagen Golf TDI 1.9 or something like that. And check out that MPG, right? 41 to 49 on the highway. I was regularly getting like 48, 49 with that car. So this is something you totally can look up. And the reason they have a range on it is because that's for automatic, that's for manual. And now, of course, they're taking manual away. Just a little critique on society here. I was like driving a little stick car, honestly. All right, the last thing that we're getting as an input is the price. So like, what is the price per gallon of fuel these days? And that's also variable, right? Like you can go to one gas station and they can charge you 30, 40 cents more a gallon than some. So it pays to shop around, especially if you drive a lot. I'm not trying to plug any companies, but there are places that are cheaper than others. So we got the inputs. Now we're going to do our processing. And let's think about this here, because when we talk about what we're supposed to calculate, it says print the cost per 100 miles. What does it cost to drive 100 miles in the car? And how far can the car go with the gas in the tank? Two interesting calculations. So I'm going to create one variable called cost per 100. right? And then we have to figure out what the calculation is. All right, if you're not sure how to calculate that, how would I figure out how many miles I can go on 100, or how much gas I use per 100 miles? Now, this is a pretty basic calculation. You might not know it off the top of your head, but basically you would take 100 miles and divide it by the miles per gallon. That's the calculation. So that will tell us how many miles we can, or how much, or what is the calculation there? It's going to tell us how many gallons we're consuming, right? And then I would multiply that against the price to get the total. So I would do this. Now, question. Would the order of operations handle this correctly? Or does it make sense to put parentheses around this part of it? Like figure out how many gallons you need first and then multiply it by the price. My suspicion is it'll work out either way, but my brain is telling me to put parentheses here. And I'm looking at my previous example, and that's what I did. So I must have done it for a reason. If you're just doing it for your own sake, that's fine. Right? So that would give us that calculation. The next one is how far we can go. Let's call that distance, right? Given the MPG that we have, and multiply that against the amount in the tank. So I'm calling that tank amount. Maybe that's not the best name. Maybe it should be called fuel capacity, but that's what I chose. So that's what I'm sticking with. So that's that calculation. Now, if you weren't sure about these, and once again, this isn't a math class, just remember you can go out there and Google this stuff. If you want, you could ask your AI, hey, what formula would I use to calculate the cost of driving 100 miles for a car? And it would give you the formula. Next, we'll go to displaying the output. Once again, I'm going to do this, now that I'm thinking about output, I'm going to do a \n here, blank line at the beginning. And then I'll do the same thing with the print statements I've been doing, which is to make a little generic F string thing. And then I think I need probably like 2 of these, maybe 3. Let's just go with 2. I'm going to start with a blank line on the first one just to create a little bit of space. And now I just got to put this in a format that makes sense relative to what we're doing. So I think I'm going to say it takes, and I put in a $sign here because we're looking at what does it cost basically to go 100 miles. And there we will put in the cost per 100, and we'll format it. Well, this is a monetary amount, so it's 2 decimal places, 2F. And then I want to finish my sentence. It takes X amount of money and I'm just trying to think of a good word of, $5 of fuel to drive 100 miles. And we'll end our sentence. And then down here, and you can word that a bunch of different ways, and maybe you have a better wording than me, so go for it. And then the other one here is, let's say the vehicle can travel how far? What's the distance? This many miles with the fuel in the tank, right? I'm not assuming that it's full, but right, maybe you only have a half tank, or maybe you went to the gas station, you only got $10 worth, or whatever. All right, let's run this. This is the completed program. Oh, you guys didn't catch me. I didn't do a save as. This is exercise 211. So if you didn't save yours, save it now. Let's go ahead and run this. I'm going to kind of move the console up here. Here's the run. Enter the fuel capacity of the vehicle. So I'll start with my gas guzzler, which is my Toyota holds 18, right? And the MPG of the vehicle, and you know what? I'm going to look it up. So, and I'm going to look at the average here. So I got an '06 Highlander MPG. Yeah, that's about what I get. Not great, right? So we're going to go with 19 as our number. I'm going to type in 19. Enter the cost of a gallon of fuel. Okay, so the last time I got gas, I think I paid 2.89, 2.899, actually, technically. So I'm going to put that in. So it takes $15.26 of fuel to drive 100 miles. The vehicle can go 342 miles with the fuel in the tank. All right, I'm going to run this one more time. Okay, the fuel capacity of the vehicle. Now I'm thinking of my old diesel Golf here. The MPG, and I think I had a tab open. Well, I guess it was the previous search, right? All right, so they don't really give me a clear thing. I know that on average, I would hit about 41 miles to the gallon, and I think that's pretty close there. So I'm going to use that. I'll use that 41 as the number on this one. So we'll just say 41. Cost of a gallon of fuel. I'll use the same price. So we're comparing apples to apples, right? And notice the difference in fuel cost. It would cost me like less than half as much to drive that car to work, right? And look how far I could go on a tank of gas. Isn't that crazy? 533 miles on one tank of gas. And that's mix of highway and freeway. Go on the freeway, it would reach almost 600 miles, on that car. So these are the kind of calculations you should do. So like if you're driving to work, you should calculate that, because if you go like 5 days a week and you're saving $8 each day, that's $40 a week. That's that's a lot of money each month, and you could be doing something with that money aside from buying fuel. Right. So these are the kind of calculations you do. So that was exercise 211, folks. Is everybody okay? No errors or glitches? Am I going too fast? Right, a couple thumbs up there. All right. Let's move on to the last exercise here. The last exercise is exercise 32. So that one you got to scroll a bit for. It's way down here. There it is. Now this one's kind of an interesting one because they kind of give you pseudocode, and then you have to turn this into a program. I have kind of previously captured the pseudocode, but basically the thing is, this pseudocode describes how a bookstore computes the price of an order from the total price and the number of books that were ordered. Read the total book price. In other words, get that from the user. Like, how much did you pay for your books? Compute the sales tax, and in this case, it's 7.5%. And then compute the shipping charge of $2 per book. And then the price of the order is the sum of the total book price, the tax, and the shipping charge. Print the price of the order. And it says translate the pseudocode into a Python program. So like, this is the kind of thing, like if you're dealing with, like, for example, normal human beings that want you to write a computer program for them, this is kind of how they might contribute their information. They would not talk to you in coding terms. They might not talk to you in formulas, but they can tell you what they want, right? So this is not an unusual type of ask. So I have the programming prompt, or at least the pseudocode part of it, captured. And I'm going to go ahead and make a new program. What am I supposed to do first? Save as. All right, this is exercise 2_11. Oh, sorry, not 2_11. So I don't want to replace, this is 232. There we go. And here's the pseudocode for reference. And then a couple of things we should talk about here, right? Are there pieces of information here that are implied constants? This is kind of a trick question because we know in Python we can't do constants, but there are two things that are kind of hard coded values. One is the sales tax rate, right? That's not something that really changes a lot. Not that it can't change, but it would take like a, act of legislature or whatever, or some legal proceeding to make it happen. And the shipping charge seems to be fixed at $2 per book. So what you might want to do is declare those two things as constants. You might want to drop them in that format that we learned. And remember, in Python, these are implied constants, but I name them in a fashion that is clear as to what they are. And I use all caps with underscores separating the words to imply that they're constants, even though they're not. Right. Next task is to get the inputs from the user. So we're going to ask them the piece of information because we need to, it says read the total book price and number of books. So we're asking the user for that information. So let's create a variable called book price. Whatever it is, we're going to convert it to a float because it's numeric, right? Or it's monetary. And then inside there, we're going to do an input prompt. And that will read something to the effect of, and you can engineer this any way you want. I'm going to start with a blank line though. And I'm going to say, enter the total cost of the books. Because that's kind of what it's asking for, right? It says total book price. It doesn't say, how much did you pay for your Java book? How much did you pay for your Python book? How much did you pay for your database book? It just says the total cost. So that's what we're getting, converting it to a float and saving it. And then we're being asked for the number of books. Now, folks, that's a counting number, right? Because you're not going to have 2.75 books unless you tear off the cover in a few pages or something. So that one we're going to convert to an integer. What's the total price you paid, right? Because it might have dollars and cents. And then how many books did you buy? Next, we're going to move on to do the processing. So we're going to do the math. And let's think about this. What are we being asked to compute? Right. Well, the sum of the total book price, well, we already have that. That's a given. We have to compute the tax at a 7.5% rate and then the shipping charge. So let's do the tax first. That seems pretty easy. So what's the tax going to be based upon? Well, the tax rate, right? And then we're going to multiply that against the book price. Now, notice the tax rate is set to 7.5%. And notice that, this is a 3-digit decimal after the decimal point, right? Because 0.07 would be 7% instead of 0.075 is 7.5. Just in case you forgot. You could also have it listed there 7.5 and then divide by 100, whatever. I prefer to list it like that. Next calculation. It's the shipping. So for this one, I created a variable called shipping, and I just take the number of books and multiply it by the shipping cost. And yeah, I could hard code, right? And I just want to kind of make this point. I could hard code a 2 here instead of the implied constant. And I could hard code the tax rate. I could do that also. But think about this. If I wrote a program that referenced the tax rate 50 times and the shipping rate 40 times, and then I had to change my code, I would have to go through and find all the spots where it was. Hopefully, maybe there's not another number that's 0.075 or 2.0 and change them all manually. If I refer to the same variables over and over again, I can change them in one spot up here, and then it would propagate all the way through the program. That's one of the reasons why we set constant values like that. And then finally, we have to calculate the total price, and they tell us what the total price is above, by the way. That's the book price, the total cost that we paid, plus the tax, plus the shipping. And then that gives us the total. Of course, from there, we go to output. So from there, let's put a little comment in there. Of course, we're going to use our F-string approach here. I'm going to start with a blank line in there. And I probably shouldn't have put the blank line in first. Let's copy and paste this a few times, because what do we really need to display? And ultimately what they're looking for is the total price, right? That's what they're really looking for. But think about this. If you walk into a store and you buy some stuff and you check out and you get a receipt, what do you want on your receipt? This is the kind of question I start to ask people when they're coding programs like this. You want a verbose receipt. You want to really, ideally, you want to, it's like you bought this book at this price and you bought this book at that price and this book at that price. And here's your subtotal. And here's your tax at 7.5%. And here's your shipping charge per book. And here's your grand total, right? That's what you want to see on your receipt. You want an itemized receipt. And so what I always tell students is when you do stuff like this is kind of like a primitive cash register program, very primitive, but it doesn't mean your output has to be primitive, so think about that. I think it's always a good idea to be verbose in your output. So I would say something like your subtotal $, right? And then once, of course here, what's the subtotal? That would be the book price. So I would say book price, and we'll format that. All this is going to be money formatting. So .2f is going to be over and over again. So that's your subtotal. Then we're going to do, let's see, I forgot to copy paste this stuff. Yeah, and I see your comment there, Jared, about the previous exercise. And let's just kind of be nice here and copy paste this to save a little time. And of course, why is it indenting? Because I forgot to close my double quotes here. We're going to talk about indenting next week. We start talking about if statements, by the way. I think that's probably enough. All right. Then we'll say number of books. Well, this one we don't have to format, right? We can just say num books here. Oop, don't forget the closing curly bracket. The next line might say something like sales tax. And you could throw in 7.5% if you want. In fact, I could just do that. 7.5%, 7.5% sales tax. And then inside here, it would just say tax. And then, of course, .2f. For the next line, we'll want to detail the shipping. So shipping and then we'll do that as a dollar format also. And that variable is called shipping colon .2f. And then one more line here. Finally, the total. And I might suggest, right, that you maybe put a blank line here. And that's very subjective. Total. And then here, of course, this is a monetary format again. And our variable is called total price that we're outputting. And we'll do a .2f formatting on this again. All right, let's go ahead and try to run this and see if it works.
Wait. Okay. Never mind.
Yeah.
No, let it run.
Okay. If there's a reason that you want me to stop, you can always still look at my other screen. So let's just come up with an amount. Let's say $100 for books, right? So using numbers that are easy to calculate. We bought 4 books. And so the subtotal is 100. The number of books is 4. 7.5% sales tax is $7.50, which is correct for $100. And the shipping for 4, and really I should probably say 4 books.
Yep.
That type of thing. The other thing that you can do, like if you want, right, like you could go in here and some people will do this kind of stuff and they will make everything line up really, really beautifully. so you can just do it with spaces if you want. There's also, you can use the string formatting commands, and I really did not get really heavy into that.
Okay, so here's my quick question.
Yes, go ahead, Danny.
If you, on your second to your bottom line, line 28 there, if you hadn't inserted books, let's say you wanted to multiply the shipping by the number of books, is that where you would have put your multiplication then instead of books?
No, I mean, you could do that, but here really the calculation is happening somewhere else. We're just displaying it,
Yeah,
right?
I was
Could I
just,
have forced the math inside here? Yeah, you could do that. I mean, that's a feasible thing to do. Um, and I think there's plenty of people that would do it brute force like that. I think in general though, this type of calculation probably, is better handled separately, because once again, if you go to tweak it later, it's easier to tweak it there than to go into a print statement and tweak it. Let's try a different amount here. All right, and that didn't turn out so great, but this is where we can get into the realm of like, how do you format stuff so it all lines up? And the truth is, I don't want to spend a lot of time on that in this course, but if you go back to the unit folder, right, and you look at the string formatting approaches here, there's a whole collection of string formatting that you can get all the stuff to line up beautifully, right, if that's really a concern. But my general point is here that you say like I should have had like one less space here, and maybe the number of books could be somewhere else, that type of thing. But it's not really far away from like the output of like what gets printed on a receipt, if you guys feel where I'm going with it, right? And here's kind of like this other like thought you might have. It's like whenever you go to a point of sale and you're buying a product, and people are scanning your thing and it comes up on the register screen. Look at the register screen. Sometimes somebody's got to code that, and then look at your receipt. At some point somebody's got to code that too, right? And you can feel like the code for it isn't really all that far off of what we're doing here. It's clearly more complicated, but somebody's got to code that stuff. And folks, this is kind of like the start of like a cash register program. Very, very primitive, but start towards that sort of thing. All right, that completes the canned exercises. So I'm going to go ahead and stop the recording here. So this recording is over.